Welcome to This Explainer. Today, we are diving into something absolutely fascinating, the actual, empirical data science behind how we human beings really communicate. We're going to take the words we use every single day, pull them apart, and look at the hidden matrix right beneath the surface using a field called Corpus Linguistics.
So, do you know how you actually speak? I mean, most of us think we do, right? We use language effortlessly all day long, so we naturally assume our gut feelings about our own speech are pretty much spot on. But as data scientists in the language space are quickly discovering, our intuition is often just wildly wrong. What we think we say and what we actually say are two totally different things.
Okay, let's dive into this. To really wrap our heads around it, we have to look at something linguist John Sinclair pointed out back in 1991. He said, "A word in and of itself does not carry meaning, but meaning is often made through several words in a sequence." That idea totally shatters the illusion we all have of isolated words just floating around in our heads like little dictionary entries. Instead, it introduces us to the macroscopic lens of corpus linguistics. Suddenly, meaning is found in the statistical sequences and patterns, literally watching words dance together.
Here's our roadmap for today's explainer. We'll start by looking at the data science of language, check out the anatomy of a modern corpus, see how we tag and process all that data, discover some hidden language patterns, and finally, weigh the real-world impact and limits.
Section 1. The data science of language. We're moving from gut intuition to hard data. You see, corpus linguistics isn't just some abstract theory you'd read in a dusty textbook. It's a rigorous, empirical methodology. It's about actually proving how language works using cold, hard evidence. So the crucial point is figuring out the boundaries of what this linguistic telescope can actually see. It's incredible at revealing word frequency patterns across billions of words. It shows us how language completely changes depending on the setting, like spoken versus written, and it identifies which words practically insist on hanging out together. But it cannot provide what we call negative evidence. Basically, it can't definitively prove a word sequence is impossible, just that it didn't show up in the data pool. It also can't explain why these patterns happen, and it definitely cannot replace your own human intuition.
Now, any modern linguistic data science project is built on four non-negotiable pillars. First up, it's empirical, based entirely on natural, uninvented, real-world language. Second, it's principled and large-scale. Researchers aren't just dumping random texts into a folder, they construct it very carefully. Third, it is totally computer-assisted, heavily relying on statistical software to crunch through millions of words. And fourth, it uses a dual-method approach. It hands us the cold, hard quantitative numbers, sure, but it still relies on human analysts for that crucial, qualitative, interpretive insight.
Moving right along to Section 2, Anatomy of a Modern Corpus. Building the ultimate linguistic telescope. If we're going to look at the stars, we need to know exactly how the telescope is built, right? A corpus, which, fun fact, just comes from the Latin word for body, is a carefully constructed body of text.
It is seriously amazing to look at the sheer magnitude of growth in this field. Back in the late 19th century, dedicated lexicographers were out there literally writing down examples of language by hand on little paper slips. Fast forward to 1961, and digital computing gave us the brown corpus, holding an unprecedented 1 million words. And today? Today we have things like the corpus of contemporary American English, towering at over 1 billion words. I mean, what a breathtaking leap, from tiny paper slips to massive billion-word digital databases.
But hey, there's a massive misconception we need to clear up right away. Representativeness is way, way more important than raw size. Think about it. If you have a massive corpus of 1 billion words, but it's purely made up of dense legal contracts, it's totally useless for understanding everyday conversation. A smaller, perfectly balanced corpus that captures a real mix of authentic speech, news, fiction, and academic writing, that is vastly superior.
Okay, let's shift gears to Section 3, tagging and processing data. Think of this as the assembly line of language analysis, where raw, messy text gets magically transformed into searchable, structured data. So here's how that magic happens, step by step. First, we take the raw text, simply digitizing the actual speech or writing. Second, we add markup. That's just the objective metadata, telling the computer the author, the date, and where the paragraphs actually break. Third is POS, or parts of speech tagging. This is super cool. It's where the computer automatically assigns a grammatical category to every single word, like instantly flagging jumped as a past tense verb.
And finally, step 4 is semantic annotation, where the computer encodes the deeper meaning and emotional polarity behind the words. Now, what's really interesting about this slide is this simple but absolutely crucial concept, lemmatization. All this really means is grouping words by their family tree. Say a researcher wants to study the verb to do. Well, they don't want to run separate searches for do, does, did, done, and doing. That'd be a nightmare. Lemmatization automatically reduces all those inflected forms down to their core base form, or lemma. It makes heavy-duty analysis possible so we don't get lost in the grammatical meads. Which brings us to Section 4, Discovering Hidden Language Patterns, the matrix of our daily communication. This is where the data really starts to challenge our everyday assumptions, and where things get really fun. Take the word very. In spoken English, it shows up over 2,500 times per million words, but in written English, only 673 times. That means we use the word very almost 4 times more frequently when we speak than when we write. No way we'd know that without the data, right? We'd probably just guess very is common everywhere, but the data reveals this massive, hidden asymmetry. Another hidden pattern is collocation. That's the statistically significant tendency of words to co-occur. Basically, words actually have mathematical preferences for their partners. Think about it. You might be a strong supporter of a cause, but you use a powerful tool. You'd rarely, if ever, hear someone say powerful supporter or strong tool. It just sounds weird, right? These words are statistically bound to each other, and Corpus software maps out these invisible magnetic poles between them. And this brilliantly illustrates one of the most fascinating findings in the whole field. Vocabulary and grammar are completely inseparable. Take verbs like know, matter, and suppose. They naturally demand to be in the present tense over 80% of the time. On the flip side, words like smile, reply, and pause practically live in the past tense. It's wild. The word itself is literally dictating the grammar. All right, let's move into our final section, real-world impact and limits, where digital humanities meets reality. Because, why does crunching billions of words actually matter outside of some university laboratory? Well, it matters because it literally powers our modern world. Every modern dictionary is written using corpus data to make sure the definitions actually match reality. It's used to create highly specific training materials, think specialized English for aviation pilots or medical nurses. And maybe most importantly, it is the absolute foundation for natural language processing. This is the exact kind of data that trains your smartphone's predictive texts and voice assistants. It's everywhere. But we definitely have to keep our analysis balanced here. Text corpora can't capture a sarcastic facial expression or hand gesture. And because they require transcription, capturing completely unedited, raw spontaneity is still really, really difficult. Also, and this is key, a corpus only shows our performance, what we actually said in that specific moment, not our underlying competence, which is what we are intellectually capable of saying.
As linguist Gina R. Bennett points out, corpus linguistics allows us to see how language is used today and how that language is used in different contexts, enabling us to teach language more effectively. And honestly, that is the core takeaway of this explainer. Objective, massive-scale data replaces our flawed human intuition, giving us grounded, powerful tools for teaching, computing, and truly understanding human connection.
I want to leave you with a final, provocative thought. In an accelerating age of AI and machine learning, how close can a digital database ever get to capturing the true, unedited spontaneity of human performance? As algorithms get better and better at mimicking us, the lines between authentic human language and digital data are only going to blur even further. Just think about that the next time your phone auto-completes your sentence. Thank you so much for exploring this with me today, and keep learning,